Thrilled that we've had such terrific turnout. Thank you everyone for joining us. Joey, you want to say any kind words here?
Yeah, just thank everyone for coming once again. And we know that, it's a difficult time out there, so we appreciate all the support and all the human interaction that we've gotten over the past couple weeks. So
Excellent.
yeah.
Yeah. Well, one thing I decided to do was add the word applied to building science. So I think now I'm thrilled that we've kind of gone through the basic concepts, and now we can really start applying our foundational knowledge to applications, which to me is just really exciting. And before we go too deep, I want to give a shout out and a special thanks to our friend Chris Conway in Virginia for helping to review this content and understand it, and also our very own Paul Blazin of Southface Energy Rated Homes, our providership wing of Southface. So appreciation from that. Joey, you want to do quick housekeeping?
Yeah, I can do that. So first of all, everyone's in listen only mode, so don't worry about muting your mics. Second of all, you'll notice that there's no chat feature, but there is a Q&A. So if you have any questions, concerns, or anything, just shoot those through the GoToWebinar interface. And right below that, if you look at the screenshot here, you should see something that looks like says handouts, and we do have 3 handouts posted for today's, and they're all very informative. It's not required that you have them open at the time of the watching, but they will be certainly helpful. And the Understanding Insulation Grading PDF, that's actually a copy of these slides. So we'll also send those out after, just in case you can't find them. We're pretty flush on topic ideas, but keep them coming if you've got something you really want to hear about. And do
Definitely.
keep in mind, this last one is especially important today. We're going to be talking a lot about RESNET standards, but don't dismay. For my BPI friends out there, there's a lot of great content, and it's definitely applicable to what we're doing out there in weatherization.
For sure. And we just, again, Joey, really quick 10-second introduction of yourself.
Sure. Speaking of weatherization, I am kind of Southface's go-to when it comes to the weatherization. About 10 years of experience in energy efficiency, and a lot of that is in weatherization and quality assurance.
Yeah, and I'm Mike Barsick, and I do a lot of our technical training, residential and commercial. And I did think I'd share that, in this day and age, especially with the pollen and stuff, I have occasionally been coughing, and this is my technique, but I thought it was interesting Joey had to one-up me with his technique. So, I don't know how you put all this together. It's impressive. So, are
You
you
gotta look
detecting
out.
a theme?
Gotta look out for
Yeah.
everybody there.
That's it. Also, I thought it was kind of funny because I feel like this topic, I'm qualified to speak on insulation because my own attic is kind of a museum of insulation. I've been doing some work up there, um, and I noticed that I have rock wool, cellulose, fiberglass, and denim, cotton insulation up there. That's all the loose fill. And then I have bats that are pink, brown, gray, and white. So I have different manufacturers and different products represented up there. So that's pretty much whenever I come across insulation scraps, they end up somehow in my attic. So I thought that was kind of funny. Our organization, Southface, I think hopefully you've learned who we are. We're based in Atlanta, but we work all over the country, and we do a lot of training in the world of energy efficiency. And Joey, we are on our 4th topic today. This is insulation quality, having kind of knocked out the first 3 fundamental concepts. And then schedule-wise, we are going to, next week will be our next one. It'll be on the Thursday, the 30th. And I believe we're going to try to make them every Thursday from here on out. Is that correct?
Yes.
Okay, so I got that right. And also, while we're on it, looking at the calendar, tomorrow, want to wish everybody a happy Earth Day. And we kind of think of every day as Earth Day, so we're excited about that. And most of the people on this call do work in this world of efficiency and weatherization, so we're grateful for the work you do, which is helping to manage our finite resources wisely. So thanks again for everybody's efforts. Let's see, anything else we want to mention on here? We've mentioned multiple times there's a lot of good free resources at southface.org, including some energy code stuff. And this booklet has a lot of air sealing and insulation details in it. You can download that. It's phone friendly. And we're not going to do a poll today. We just thought we'd kind of say this is the list of people that have been showing up for these webinars. If you're not on that list, then maybe send a little message back to Joey and say, hey, you forgot about me. And I'm sure we did forget about somebody. And Joey, do you want to make a comment on the box at the bottom there?
Yes, like I said, this webinar is really going to focus on that RESNET insulation grading system. So we are approved for RESNET CEUs. If you attend this webinar today, you'll get one RESNET CEU, but you do have to do a little quiz. So once we get done with the webinar, send your name and email address to courses@southface.org. Again, this is just for the RESNET CEUs. And you'll get a little invite to log into our LMS system, take a quiz. Once you complete that quiz, Southface will verify that you've paid the little admin fee, $15, and then we will send your information to RESNET and you'll get that CEU approval.
Sounds good, thanks. And now diving in, why is building science important? I think we've made the case for that. Again, excited that now we can take our foundational knowledge and apply it to, real situations. And again, in the interest of time, I'm going to not do the poll on this today, but we ran this through, and it seemed like, Joey, if I believe we had a lot of participation in the hot and mixed humid zones last time, and but we'll try to, certainly insulation works in a lot of climates here. So we do have learning objectives. I want to emphasize we're going to really, I think, be able to hit all these. What are the things that affect insulation performance? We certainly have talked about that some in the earlier webinars. Recognize the insulation, I'm going to call them challenges and requirements that are in that energy code, the IECC. And then we're going to look at sort of 3 grading systems, the original or Coca-Cola Classic RESNET grading system from 2006. And we're going to learn what Georgia did that was created probably back in 2017 or 18. We created probably 2018, a grading requirement for insulation install. And then more currently, it was released less than a year ago, the RESNET 301 standard, which has sort of revised the insulation grading, and that's something that's pretty new, and it's got definitely some interesting things. We're also going to look at a number of photos and talk about situations, and this is one from a January project that I was involved in, and I got to say, this was the quietest insulation blowing machine I've ever experienced. It was amazing. It was very slick and very easy to do, and just so much quieter than the machines I'm used to. So shout out to that design. Again, this shows up in just about all of our trainings. The house is a system. We're going to really focus on the building thermal envelope aspect of it, and of course acknowledge the people component. And we want to make good decisions. I am always wary of homeowners that self-assess their own energy problems or comfort problems or durability moisture problems. Many times they assume their bills are high, I must need more insulation, and it's just that's why I really try to encourage homeowners to get a professional involved. And the professionals that we train, I think, go out and do great work. So I certainly want to help promote their efforts. And heat, air, moisture. Heat, of course, the big one we're going to be covering today, the 3 types of heat transfer: radiation from hot surfaces to cool, conduction, that's the one through solids, and then of course convective. So with conduction, we use insulation to slow it down, and that is the key element of what we're going to cover today. And then lastly, I think hopefully everybody remembers this equation, that the heat flow is a function of 3 things multiplied together: the U factor, which is the inverse of the R value, times the area of the surface we're talking about, and the delta T across it, the temperature difference between the inside and the out. And that answer is going to come up in BTUs per hour. So we laid the foundation there. Thought I'd throw out a question. Joey, I don't know if you want to answer this one, but this is an interesting one. Can you do a HERS rating on a new home that has very, very terribly installed insulation? Is that something you can do? What do you think?
You can do it. I don't think they'll score too great on the RESNET.
Yep, that is correct. And I always like to remind people that an actual HERS rating, a home energy rating system, you know, that's this industry, it can be done on virtually any home. And really the rating is essentially assessing what is there, what has been installed. And, you know, in other words, even though the home doesn't really pass code, you can still do a rating on it. But a lot of times a rater shows up wearing a hat, a different hat. Maybe the HERS rater shows up with their code compliance hat on, or maybe they're verifying for a beyond code program like Energy Star or Earthcraft House or any of the other programs out there that, you know, I'm verifying for a program and this does not pass the spec of a program. So just, you know, kind of keep that perspective in mind. The original insulation grading standard really dates back to the 2006 RESNET standard, I believe, is when it first came out. And RESNET went through a major overhaul, I guess, of their standard in that era, because before that, the HERS industry was actually using a reference homes based on the 1993 model energy code. And in this era, they updated to what is effectively the 2006, or the U factor table from the 04-06 energy code. And that, just for reference, is still the code today, or it's still the reference home today. So that has not changed. But that was that's my first recollection of seeing insulation grading. And they came up with this process. A lot of people are probably familiar with the grade 1, grade 2, grade 3. And I would always say grade 1 is, you know, what you paid for, it's the brochure. Grade 2 is they probably tried. And grade 3 is, maybe I should say standard construction at the time, at least. It was a way, it was certainly an attempt to try to put some boundaries on this, but it's definitely subjective. It's inherently subjective. And I thought I'd kind of review these. So one of the most important things, as I read this, is that they really kind of had two criteria they were looking at. One is, they call it gaps and voids. And this is places where you can literally see all the way through, let's say, a wall cavity to the sheathing on the backside. There literally is no insulation in that. And they used to call that a gap or a void. Excuse me. The other thing is that, okay, there is some insulation, but it's not the correct amount. It's not the right depth. And so that was either called compression or incomplete fill. And in order to be grade 1, you basically didn't have any gaps, and you had a little bit of compression or incomplete fill, but no more than, it had to be under 2% of the area. So if this is, let's say, a 10-foot by 10-foot, 100-square-foot wall section, less than 2 square feet can be, in essence, under insulated. And the amount of under insulation, there's a depth factor there too, which was 30%. And to turn that into something meaningful, if that's a 2x4, 30% is about an inch. So that would define grade 1. And then grade 2, you're allowed to have some areas where you could look through and actually see the back, but it had to be less than 2% of the surface. And then your areas that could be compressed, they're insulated, but they're under insulated, had to be less than 10%. So 100 square foot, you could have, 9 square feet that was showing some compression. But again, it could not exceed 30% of the intended depth, which in this case is about an inch. And then grade 3 is where you had more voids than 2%, or 2% or more, but you still had an upper limit. You you could not have more than 5% gaps or voids. And if you were more than that, then basically what you'd say is, okay, you know, some of this wall is just uninsulated and the rest is grade 3. They also had a criteria for compression that said you're more than 10% compression, equal to or greater than 10% compression or incomplete fill. But again, that depth of 30%. If you were more compressed than 30%, then you were essentially out of grade 3 and essentially just degraded. So I know that's a lot to take in. Let's try to work an example and see if we can make sense from this. So here's a 2x4 stud wall, has 1% voids, and it has 8% compression. And the depth of compression is anywhere from 1/2 inch to 1 inch. Joey, you want to take a stab at this? What, based on what we covered, what grade would you do this based on the old standard?
Is that grade 2?
That is correct. Grade 2 is, and the reason is because you had some more than occasional or very small. So you had some voids that was, you know, exceeded the occasional, but you were still less than the 2% threshold. And you did have some compression, but you were less than the 10% threshold. And the depth of compression did not exceed 30%. So you know, sort of ticked all the boxes for being eligible to remain as grade 2. Here's one that has 1% voids and has 14% compression, and the depth of compression is 1/2 inch to 3/4 inch. You want to answer that one, Joe?
1%. That would be grade 3.
Yeah, I gave you a very short window to answer. Yeah, and the reason is you did fine on compression. You were still eligible to, excuse me, let me back up. You were fine on voids and gaps. You were 1%. So you were still eligible to be grade 2. And your depth of compression you did fine on, but where you blew it, in essence, was you had more than 10% for compression. So the fact that you know, that amount of area was exceeded the threshold, that kicked you into grade 3. So that was just an example of that. Let's look at a couple pictures. Here I'm looking at a photo of a blown attic. I think that was cellulose. It looks like they did a pretty good job, assuming the eave details are handled correctly. I see evidence of baffles, and of course, assuming they put a dam, and the dam and the baffle to channel the air above that you're venting above and not wind wash through the insulation, also as a stop for blown insulation. You know, assuming that detail was handled correctly, I think you'd have to give that a grade 1. And I did also have to say, we're going to learn if we also need to see the presence of rulers in there, but we'll talk about that in a little bit. But I would call that grade 1. I would say here's a wall cavity photo. That looks to me, you know, looks like they split the bat around the wire. That looks like the evidence of grade 1. This one, you certainly see evidence of voids and compression, significant amounts of both. I would certainly say grade 3 on a good day. I see a little bit of voids, but I see a whole lot of compression. So no question that's grade 3. I look at this, I don't see any appreciable voids. It looks like no effort to compress insulation, or it looks to me like they did a great job. That's got to be grade 1. I see, it looks like a spray foam that was poorly installed, and maybe the substrate was cold or the mix was incorrect, but whatever, that's definitely a failure right there. And then underfloor, can't see a whole lot, but certainly looks compressed, probably grade 3. And underfloor, assuming they have the right depth, I would say that looks pretty consistent, so that's probably grade 1. We went through that pretty quickly, Joe, but any last thoughts before we move on?
Yeah, I think you keep nailing it. You know, we're making some assumptions here because we can't see the full installation. So keep that in mind if you're looking at these pictures.
Dead on. Yep. And I thought I'd mention a little bit of what we did in Georgia. So, and I'm going to give you a little background. This was our code for many years. And if you look at the climate zone, you know, I'm going to look at climate zone 3 as an example. There's certain prescriptive requirements. And we were pretty close to the 2009 IECC at the time. We were a little better on a few things, like we've always spelled out attic knee walls have to be done better and differently, but more or less on code or slightly better. And then some important footnotes that we added, for the most part, wall insulation has to be in substantial contact with an air barrier on all 6 sides. I say this is important because that language is not explicitly in the IECC. It may be inferred from some other places, but it's not as obvious. And then a couple of things like floor insulation and, cantilevers have to have more insulation than cantilevers over outside air need more R value. So one of the neat things we would do to teach is put up this diagram, and I'm going to go through it very quickly and just kind of say, what is this? That's a floor over a crawl space. How much prescriptive R value? That's 19, and so on. And so we could go around and sort of teach our code this way, and you can see cantilevered floor. And here's a flat ceiling, and that was R30. And then the change, you'll see we didn't change our code a whole lot in terms of insulation. That went to R38. You all stayed the same. So I'm kind of walking around this really quickly, but this allows us to sort of visualize what the prescriptive R values are for a house in climate zone 3. And then once we inflicted the changes of the 2020 code, I say inflicted, there really weren't that many changes. The only things that changed is the windows technically got better, but everyone was already pretty much there with their windows, U factor and solar heat gain. And the ceiling went from 30 to 38. So that's really all we changed from an insulation and window standpoint. However, we participated in the year 2015, along with about a dozen other states, in an assessment of where is our energy code and what's our, what are we doing correctly and what could we do better. And we didn't look at every aspect, but the key takeaway was we had room for improvement, as did just about every state, in the way the insulation was installed. So I'll kind of cut to the chase here. Ceiling insulation was kind of not so good, and wall insulation, everybody had the right amount of insulation, but the quality of install was blah. So those are some technical words, meh and blah. And so as a result, this was kind of what our summary was if we could sort of make these 4 things do better in our new code, that would result in some significant energy savings for new homes in a year, over $3 million. So that was kind of what we try to use data to help drive our code improvement process. And we're going to talk a lot about the insulation install. And then lastly, if you're not as familiar with energy code, it's been structured like this for many, many years. You have different pathways to show compliance. You can show compliance by simply following the recipe and meeting the prescriptive R values on everything. Or you can do a pretty simple trade-off, a UA trade-off, and a good tool for that is the free tool ResCheck. Or you could do a computer simulation. This was often not done, but you could do this, and then no matter what, you always manage to satisfy the mandatory requirements like air sealing and duct sealing. The trade-off options here, though, both of those limited you in the sense of you're really only able to trade envelope for envelope. The thing that came out new in 2015 and it carried forward in the 18 code is the option of doing the energy rating index, or ERI. And it's very similar to the HERS index, especially the 2015 version. They're very, very similar. And the biggest change here is everything's on the table now, and you can actually get credit for more efficient equipment. So this is a big shift in a new option in terms of compliance. And we'll see if anybody takes advantage of it in this new code. There's also a very important section of the energy code that I really wanted to just make people aware of, which is 402.2. And it basically says, if you have one of these in your house, read here for more detail. And I'm not going to go through all these, but I'll say the ones in bold are the ones that more commonly pop up that we see. And as an example, ceilings with attic. And here you can see R38 is the prescriptive requirement. But the national code says, hey, if you do a continuous R30 across the board here, like you see in this diagram, that's a continuous R30 is deemed to comply with a tapered R38. This is not a Georgia amendment, this is in the national code. So, and they have the same language. If it's supposed to be R49 and you do a continuous R38, it's deemed to comply. So this is a thing that's written into the national code, and you kind of learn about that when you sort of get to this 402.2 section. This is an example of a Georgia amendment. We just thought we'd try to make it a little easier. If you wanted to do an HVAC platform, ideally you would elevate it and put the whole R38 under it. But we're saying you get one sheet of OSB, and as long as it's R19, we're not going to make the builder do a trade-off. That's an example of a state amendment. Here's another IECC requirement, though, that says rulers are required one for every 300 square feet. And anyway, that's sort of baked into the code. So that's just an example of a section of the code. And now I want to kind of show you what Georgia did to create a sort of a go, no go standard. So one of the things we acknowledged at the time was that, again, we use the same language as the old RESNET standard. There's sort of two things that affect insulation performance. It's gaps and voids, and that's where you can see all the way through, and compression and incomplete fill. So keeping those in mind, that's how we sort of started from that. And then we also remember that, of course, we want our insulation to be in full contact with the air barrier, such as you see did not happen in this attic installation of a BATT, or in this BATT up against the subfloor in a crawl space. So, I walked into my friend's, actually a South Face coworker's addition was being put on her house. I walked in, I looked up, and I took this picture, and I'm like, that does not look very good. We do not want to accept this. I see a lot of compression of the insulation, but I also see a huge disconnect, probably about 5 inches of the BATT not in contact with the air barrier. So we were seeing that in a lot of installations. And many code jurisdictions, if they did a insulation inspection, it was more, do I see insulation, not is it installed correctly? So that's the education effort we've been working on. So here's what we did, and I want to give a shout out to my former coworker, my buddy Abe Kruger, who is on the RESNET board. He and I drafted this, and basically what we realized is code officials don't care about grades. They just want yes or no. They want black or white. They want good enough or doesn't pass, that kind of thing. So we wrote a spec, and it's basically for walls and ceilings, it's 1%. It has to be less than 1% voids. It is still a little subjective, but it's 1%. It's got to be less than 1%. And the amount of compression has to be less than 2%. And the depth of compression is basically 1 inch. It has to be less than 1 inch. So that is our go, no go criteria. And there's a couple other important comments too about insulation in walls has to be on all 6 sides, air barrier, and a couple other important details. But we tried to kind of put something in writing. So if a code official wants to really try to enforce the code, or a builder wants to make sure it's being done properly, they can actually point to text that's in a Georgia code amendment. And it's a lot simpler than having to go chase the manufacturer requirements. And of course, we write a spec, we wanted to put a lot of graphics and pictures. So here's showing voids on the good side and the bad side. Again, 1% is the threshold. And here's compression or incomplete fill, good, bad, and it's got to be less than 2%, and it's got to be less than 1 inch of compression. So also we have a video that is a really nice kind of, I guess it's a 13-minute video of how to do a pre-drywall walkthrough assessment, and it's basically air sealing and insulation. And then there's also tons of good stuff on this. Joey, have you heard of this thing called YouTube? I was just curious if you ever heard of YouTube.
Yeah, I've heard of it a few times. I like to spend a lot
Yeah.
of time there, probably hours and hours just watching insulation videos. That's my favorite thing to do.
I bet that's what it is. Yeah, be careful because you can go blind. But anyway, there's a lot of content there and some very good videos. One that I thought really did a nice job of just sort of saying, here's what you want to do with bad insulation in a wall. And just anyway, lots of places to sort of see how to do it correctly. And then for sealing, again, we tried to do really good diagrams. These are in the amendments. They're also found in the Georgia Field Guide, uh, along with photographs in the field guide. You know, this diagram I think kind of shows all the stuff we're looking for. There's a dam for loose fill insulation, not to fill up the soffit vent. There's a dam around attic access. There's a vent baffle. There is an attic ruler. There's a attic report card. There's the right kind of can lights and good consistent coverage. So there's a good. And then there's also a bad, and it's everything that's not done correctly. And then if there's a good and a bad, that means there has to be an ugly. So I just had to put those in again. More pictures of installation I was seeing, and it's just like, this is not meeting code. So Joey, you I thought made a nice analogy here. You want to kind of talk about this? The idea
Yeah,
that blown insulation looks like a
sure.
pond.
When I first started blowing insulation, someone told me it should really resemble a still pond, and I don't know why that stuck with me, but it did.
I like that.
And the concept really that we've looked at mathematically is that those minor deficiencies, 1%, 10%, if those are lower than the rest of the attic, then you're going to have a much greater impact on the effective R value than you would think. So if you look at something like this, we've got a standard attic. Maybe we've got a couple of depth markers out there. And Mike, I think you have a theory about those depth markers. What
Yeah,
does
they're
that mean?
magnetic.
They're
I like
magnet.
your drawing here. They're magnetic because they attract the insulation to them. So the insulation looks nice and deep right here where the
Yeah,
marker is, but
yeah, about
it's the
16
valleys
inches.
that hurt you.
Yeah,
Yeah, how's that
so
happen?
yeah, it's really remarkable. So if you have some of those magic magnetic depth markers, then put a few more of those up there, and then maybe the insulation will be a little bit better. We kind of kid about the depth markers. I know that if you're blowing insulation weatherization, you have tight budgets. You don't want to use too many, but they're about 10 cents each. If you can't get more of those, then mark it off on the vertical trusses. Maybe build some out of cardboard scraps or drywall scraps or something like that. And that way you have, it's tough to see up there, and that'd be my other recommendation is just to bring more light, and you can really see and do a better job up there. So you see here in this example,
Yeah,
this is a kind of a cold weather example. Maybe some of our friends from Chicago, their code specifies R49. So
yeah.
if half of the attic is R49 and half of that is an R20, you would think, oh, well, the average of that should be somewhere around 35 or so, right? Well, that's not the case. It's the effective R value is actually an R28, just the way we do the math on the BTUs. So
Yep.
keep that in mind. Those valleys hurt you a lot more than you would think.
Excellent. Thank you. And just to wrap up, Georgia wrote a similar spec for underfloor insulation. It's a little bit more lenient than the wall and ceiling one, just because floor insulation is tough. And there's some good diagrams and that kind of show a good and a bad. And shout out to my friend Chris for sharing a couple images. I think were really good. That these are kind of classic problems where the bat is not in contact with the air barrier, and definitely that's a failure. And that might be the only floor insulation with fiberglass I've ever seen that looks like it has a chance of staying in there. I think that's an interesting one. This one looks really nice. This sprayed floor insulation is pretty good. As a general rule, I'm much more of a fan of insulating the foundation walls and not trying to do the floor, just because I think there's too many problems in the way. But if you're going to insulate a floor and you want it to work, I would say you probably ought to go with a sprayed insulation that's going to stick. So. And then lastly, just to wrap that section, I want to mention there's this issue of vapor retarders, which we touched on under the moisture one, but Joey was kind enough to add a little detail here. So just quickly, if you're in climate zones 1, 2, 3, or 4, there is no requirement for any sort of a vapor retarder. And if you're in climate zones 5 and up, then the answer is they would like you to have a vapor retarder. And that here's the classifications, which we alluded to, I think, on Tuesday, that, you know, the class 1 are the very low permeability materials. And again, I'm wary of putting those in. I think a class 2, you know, anything that's a permeability of 0.05 or whatever, that's just not much drying potential there. And so make sure you know what you're doing. I would say stay away from plastic if you've got to do it. And honestly, when you prime and paint a wall, you can get the permeability right around a 1 or a 2, and that's pretty good. So here's a little more detail about who might need this and where you might not have to do it and things like that. And I like that they do say, you know, don't put plastic in your basement wall. That's a good way to kind of trap moisture. So be wary of that. Now we are able to dive into the new standard, looking good on time. The new standard 301, I wanted to point out that the way it models this is really more or less carried forward from the way it was modeled under the old standard, but I thought it would be good to review this. So if you're grade 1, again, you're modeled pretty much with that being done perfectly. And if you're grade 2, we're assuming in the model that you have 2% of your, let's say your wall is essentially not insulated. It's an empty void. And if you're grade 3, then it's going to be a 5% void. So I thought I'd work an example here. This is grade 1, and here you can see a pretty standard 2x4 wall cavity. We've got air films on the outside. We've got air films on the inside. And those two air films, at least when I was in engineering school, they typically add up to be, you know, almost a 1 R value. You've got some sort of sheathing and maybe, you know, cladding. We're going to just give that a 1 for those R value of 1. And those are, of course, continuous. And then, of course, on the inside, we have gypboard, and it's continuous as well. And it's about almost an R of a half. So then you have either stud cavity, which is R13, or you have wood framing, which is about an R4. So when you kind of work the math on this, you have to assume a percentage framing factor. So how much of that wall is actually cavity and how much of that wall is stud. And a lot of people are surprised that it's nearly 25% wood. So in our example, we're going to take a default of 23%, and that means the rest is cavity. And when you do the math, again, you can't average R values. You have to average U factors and then invert it back into an R value. So the U factor in this case is about 0.085, and if you flip it over, that's about almost an R12. So that's grade 1. You only have 2 parallel pathways, through the insulated cavity or through the wood framing. When you jump to grade 3, I'm just going to jump over here, you have a third pathway. You have cavity and you have wood framing, but you also have voids. And the voids are the 5% part of the cavity that essentially you can see through. So if you do our same weighted average again for U factors, 23% is wood, 72% is the cavity, and then the 5% is voids, you get a different U factor, and higher is worse on U factor. And you invert that, and now instead of being nearly R12, you're closer to R10. So that's the impact of those voids in a 2x4 wall cavity. And that's how the model, the simulation, is going to run it. It's going to use those 2 different U factors. Okay, so a lot of work went into creating this standard. It is, you know, the effort of committee work, and that's always a challenge, and we thank them for their efforts. I think it's a lot of technical content. They also tried in many cases, this is an ANSI standard, so it was created with a lot of stakeholder input, and they also tried in many cases to relate to ASTM standards, and we'll talk about that. They do some good things to clarify it. One thing I really like is that they break it down by insulation type. And they specifically sort of redefine grade 1 and grade 2. And they also say if you're not one of those, you are by default grade 3. So that's good. You can still also be uninsulated too. That's in there too. So again, shout out to reading anyone that wants to read these ASTM standards. Joey, have you ever read any of them? Because they're pretty painful.
Yeah, they're highly technical, and you'll notice, the RESNET standards are based off of them, and we've tried to kind of distill that information. So what you're seeing is our best effort to simplify this, if you can believe it.
Yeah, yeah. I read this one, and it wasn't terribly exciting. They also start off with some nice general things about insulation. And this is in normative appendix A, which I believe you posted.
Yes.
They say insulation has to be installed per manufacturer's specifications, and if you have two different kinds, we don't want any air space between them unless it's a reflective insulation. And insulation has to be installed to the required density and the right thickness and whatever it is to give you the right R value. And it needs to essentially work around obstructions. So there's not going to be any voids or gaps. And I thought this was good that in general, what they're saying is, grade 1 is really minor defects, pretty darn close to perfect. Grade 2 is, moderate defects. You can decide whether you consider that acceptable or not. And grade 3, I would say, is substantial defects. I like this picture. I might see a little bit of compression in this example. Installations that do not, again, meet 1 or 2 are by default grade 3, and they'll be modeled as such, and so on and so forth. And again, these are all general statements for all types of insulation that you see listed across the top here. And also, this is sort of an observation that you could make an argument that the energy code, because the energy code, its language is nebulous. It's in section 3 of the energy code, but it says it shall be installed according to manufacturer's instructions. And, as I see that, that's, I would argue that's grade 1. And you could say that, the code is more stringent than grade 1 because it pretty much says the insulation has to be installed perfectly. It's weak language, it's nebulous language, it doesn't help the code official enforce the code. So, it's not a perfect setup, but I think that's worthy of discussion, or at least acknowledgement. All right, so the other thing is that when you dive into a type of insulation in this ANSI document, or RESNET document here, when you dive into a type of insulation such as FIBROUS BATT, they start off with some commentary and sort of best practice type comments. So they say, insulation shall be enclosed on all 6 sides with durable materials. Well, that's true if it's a wall, but if it's in a flat ceiling, that's not true. So you have to kind of read between the lines a little bit on this. They also reference ASTM criteria. So I'm not going to go into these, but this is what the ASTM criteria refers to. And then, of course, this stuff should look familiar. They want to fill the cavity and notch around obstructions and things like that. So here's the nitty gritty though. Here's the language. So grade 1, and probably my most important comment here, Joey, is the word void is now a different meaning. Gaps and voids don't necessarily mean what they used to mean. So those words, I kind of wish they had been a little more consistent, but for better or for worse, let's try to understand what they mean. Basically, for grade 1, no more than 2%, so 2% is the threshold of the area, can show any sort of compression of the insulation or underfill of the insulation or voids in the coverage of the insulation. And that's a surface area. So again, that'd be 2 square feet out of 100 square feet. The amount of, let's say, compression or depth of the gap or whatever you want to call it is 3/4 of an inch. And they do not allow any voids from the inside to the outside. And that is consistent for grade 2 over here as well. So basically, if you can see through to the back, to the, the sheathing on the back side of the wall cavity, then you are no longer grade 1 or grade 2. So that's a very important distinction, that those words mean something different under the new standard. The other thing is that grade 2 allows you to have up to 15% instead of 10 under the old standard, can be sort of, I'm going to say slightly compressed. And again, the amount of compression for batts is 3/4 of an inch. So one thing to take away from that is, if you have paper face batts, if you face staple them, you're still eligible to be grade 1. But as we read this, if you inset staple paper face batts, then you are going to pretty much jump to grade 2. And again, you have to satisfy all of these things. If you fail on any kind of one of these, it kicks you to grade 3. So hopefully people kind of would now understand that there's a void that automatically kicks you to grade 3. There's certainly more than 15% compression here, and it's more than the depth allowed that kicks you to grade 3. So that's definitely a grade 3. All right, jumping over to blown or loose fill, sprayed, sprayed loose fill, whatever. Again, more of sort of the general rules that they want you to try to follow. And again, the reference to the ASTM standard. But here's what, cut to the chase, here's what RESNET grade 1 for loose fill looks like. And again, remember, this could be loose fill in a flat ceiling, or it could be behind netting like you see the guy doing here. And it says, very consistent language here, no more than 2% of the total shall be essentially compressed or under insulated, or have the insulation but there's a void in the insulation, and the maximum amount of depth is 3/4 of an inch. And again, no voids from the inside to the outside. And the only difference between grade 1 and grade 2 is that the 2% area is allowed to go to 15% area. So again, I would say very consistent with what we saw with batts, and very different from the original 2006 RESNET standard. So hopefully everybody gets that. I'm going to try to keep emphasizing that aspect of voids. Any voids that go all the way through kicks you out of grade, you're into grade 3 immediately. So here, you're looking at this, that definitely looks like grade 1. That looks like grade 1, assuming, again, we're hoping to see rulers. And all the other details were done correctly. Definitely doesn't make the grade here in these two. So good and bad. And they have a specific section here about sloped roofs, or let's say vented attics with these kind of eave baffle details. And just for the record, they want to see a dam insulation chute at every cavity. So that's let's clarify that every cavity has to have the block and the air chute at each cavity. And it shall extend up and beyond the surface of the insulation, or run up to the ridge, depending on if it's a vaulted ceiling. In Georgia, if the bat has to, the chute has to go and extend at least to above 4 inches above the top of the insulation. That's just a Georgia detail. Okay, spray foam. This is where it gets a little confusing, and we'll just put that up front. But you can see they're trying to be consistent. Once again, they want it installed as per the spray polyurethane foam sort of industry practice. It has to be bonded to the substrate, including the framing, and it, in general, have to fill the cavity at least within a ½ inch of the face of the studs. And then here we're talking specifically about open cell. So they actually have a piece of information about how thick does the open cell have to be installed in order to be considered an air barrier. So I generally just say, I think it's 3.5 inches in an open cell is usually going to get you to air barrier status. But they don't give you a thickness here. They give you a sort of a density. And then they also say, if you're going to finish out that wall and your insulation goes beyond it, you have to shave it down. You can't squish it in there. So it has to be sort of trimmed down. Lots and lots of ASTM references. Not going to go through that. but I just wanted to make sure people are aware of that. And then let's take a look at what it is. So this one is for open cell where the cavity is not completely filled and therefore not trimmed. So they have a different criteria for open cell when the cavity is filled and trimmed. So first of all, they want you to make, and they don't say how many measurements, but they want, if you say do 10 thickness measurements, and what I usually do is take a bamboo skewer and I poke the open cell foam in a bunch of different places, and I've marked the depth on there. And they say the average of all your thickness measurements shall be greater than whatever the specified thickness is supposed to be. So if it's supposed to be, you know, let's say 5.5 inches along a foamed roof line gets you about an R20, then if I take, you know, I don't know, a dozen measurements or so with a depth gauge, that it needs to be more, they need to average out to be more than 5.5. So that's true for grade 1 and for grade 2. And if that is not the case, you're kicked out of those grades into 3. They also say no more than 2% of the insulated area shall contain voids, or and those voids or under insulated sections have to be max 3/4 inch. And I'm going to jump down here and say, once again, you cannot have any voids that extend from the inside to the outside. That's true for grade 1 and grade 2. And of course, grade 2, it jumps from that 2% to the 15%. And the 3/4 inch is consistent. Here's where it gets a little confusing. Under grade 1, and I'm not sure if this is a typo or a cut and paste issue, but they've said that the maximum depth anywhere you measure, it can be no more than 1 inch off the specified thickness. So I can't tell if that conflicts or contradicts this sentence or not. It's possible that's supposed to be 3/4, or it's possible that maybe that is a sort of a, I'll call it a worst case measurement anywhere, can be no more than 1 inch, you know, so you're trying to see 5.5 inches and you measure 4.5. That's the worst case measurement. It's not really clarified too well, and it doesn't show up under the grade 2 definition. So we're not sure if that was intentional or not. The language is not always consistent. I'll just point that out. So we're going to follow up and ask the RESNET committee to offer some clarification on that, and maybe some rewording of it just to make it more clear. There's some good pictures of open cell, and there's some absolutely fail pictures of open cell. And I unfortunately have seen this more times than I wish I could say I have, where you can literally see. I saw one retrofit attic where you could see daylight coming through the ridge vent, and it's like, you know, not acceptable. So when you get to the other type of open cell spray foam, this is where the cavity has been filled and trimmed. It's much more consistent. It's a 2% and a 15%, and it's a 1/2 inch of acceptable depth and a 1/2 inch of acceptable depth, and again, no voids. So this to me lines up better, and that's why I wonder if maybe there's not some point of confusion on the earlier one. Then here's an example of the trimmed, and it looks like they've done a great job on that. And then finally, for closed cell, just a stipulation, they actually do give depth here. They are saying closed cell insulation, that's usually 2 pound per cubic foot. Open cell is 1/2 pound per cubic foot. So it's a denser material, 2 pound per cubic foot. If you install 1.5 inches, that is up against the substrate, that is by definition going to count as an air barrier, assuming it's continuous or a component of it. So here's their layout for closed cell spray foam. Again, the average of your thickness measurements needs to be greater than the specified thickness, just like we saw before. And they have the 2% and a 1/2 inch for grade 1, and then they have 15% and a very confusing 3/4 inch for grade 2. So I think that's a consistency error. And there's that 1 inch thing popping up again. Based on my experience, I would say anytime you're using closed cell, your tolerance should be a 1/2 inch. So that's my take on this. I think this is a typo or is not consistently applied. And I would argue that 3/4 inch on a closed cell is not what you want. That you really want to see, you know, a half inch. So anyway, we'll try to hopefully get some clarification on that, but that's the way it's written as of now. So again, you know, it looks pretty consistent. We do some depth measurements, assuming that the average is good on those. I would definitely say that's a grade 1. Also, I'm checking my time here. There's a section on insulated sheathing, and the big takeaway here is the insulated sheathing has to be sealed at the joints if it's ever going to count as either an air barrier, a vapor retarder, or your drainage plane, which you know, it's a good practice to do that. And the gap between the sheathing is got to be pretty small, 1/8 of an inch. Insulated sheathing needs to be 1/8 of an inch. So here you can see sort of hybrid product being used, and here is a foam board, looks like, with some batten strips. So those look pretty good. Just to kind of wrap up here, there is other insulation that is not covered. We did not cover it today, but it is covered in the standards, such as for structural insulated panels and some of the shinier products out there. But I am thrilled we were able to make it to the finish line. And Joey, there's a couple important comments we want to put on this. And before I turn it over to you, I want to say, again, thank you to Chris Conway and thank you to Paul Blazin for their help in putting this information together. Joey?
Yeah. As you mentioned in the beginning, we're kind of changing up the schedule just a little bit on the webinar, so we will not have a webinar this Thursday. We're gonna give ourselves just a little bit of break and give you all a little bit of a break. We're gonna reconvene next Thursday, April the 30th. So keep that in mind. Mike, I don't know if you have the capability. We've actually reorganized our website just a little bit, and if you go to the South Face homepage, under the education
We'll
menu.
give it a shot here.
Okay.
All right, you never know what's going to pop up here.
Uh-oh.
So this is my solar panels for the day. They're cranking along here. But you want to go to the southface.org website?
Yes, and then on the education bar at the top.
Okay, you can see this, I hope. Let's see.
Yes, we can see it. It is a little bit
yeah, it's pretty exciting. It's a big white panel. There it is. So education.
Okay. Education. Hang on, give us just a second. We're just a second behind you on the lag.
Okay, can you see it now? Education.
I can see it, yes. So
I want to go to what?
online training. So
online training. There it is. I see it. I see it.
Yes. So
give it on that.
We don't see it just yet. Hang on.
Okay. Thanks for the heads up.
Yeah.
Anyway, you seeing it now?
Not yet. Okay. Yes, our big fans. As you all know, that's Mike on the left and me on the right. We're your biggest fan. So the next one's going to be ventilation on April 30th, and this is going to be the landing page for our webinars going forward. So if you want a fairly easy way to find out when our next webinar is going to be, you can always go to our website. Of course, follow us on LinkedIn and other social media. So yeah, sorry to put everyone through that painful process of navigating.
That's all right.
But I did want to.
I'm just thrilled it worked.
Yeah, and yeah, that'll be there. I know it's kind of confusing because it's all through GoToWebinar. So
can you see my PowerPoint at the moment?
Not just yet. Okay, there we are. And then the final announcement too, if you're here for RESNET CEUs, once again, the process is laid out here. So just email courses@southface.org. We'll get you set up with the our access to our LMS so you can take the exam. So it'll be a 15-question exam. It's pretty difficult, so you might want to study.
Oh, no. It is an open book, and more importantly, you can use the slides and the document that we provided. Is not that hard. But in fact, Joey, I wanted to ask, do we have any comments or questions from what has happened now? We've completed our webinar on time, and now we want to just kind of go to the phones and see if anybody has given us some information, or can we put up a poll question What's your preference?
We do have quite a few questions, so let's try to get through these because they are coming in pretty quick. Again,
Okay.
questions about the presentation. The easiest way to get to the presentation is through the GoToWebinar interface. You should be able to see a little menu that says handouts, and you'll be able to, the one that says understanding insulation grading.pdf, that is a copy of this this presentation. So if you didn't get that, we will send it out after the fact as well. So let me get through these. There were some questions throughout the presentation, as you can imagine. So I don't know if it's better to go chronologically or what.
Yeah, whatever. Dive in.
Oh, well, here's one that just popped up. Are the softwares, and I'm guessing like Ecotrope, REMRate, Energy Gauge, are they updated to match these new RESNET standards?
That's a good question. I believe the answer is yes. Let me see if I can find out where I started that. The softwares, actually, this didn't really change the way they're modeled here. Didn't
Mm-hmm.
really change. It's more the definition of how you come up with grade 1, grade 2, or grade 3 has changed.
Right.
But that is, to my knowledge, yes. The answer is whenever ResNet comes up with a new standard, it gets released. Obviously, the software manufacturers are obliged to keep up with that. So this
Yeah.
is one that I don't actually think changed, but if it did, it would have happened, back last year. So that's a great question.
And speaking of softwares, we have a question about ResCheck, which I think I can answer. ResCheck has not been updated to the Georgia 2020 standard.
That is correct.
We've also made some feelers to try to figure out if we can get that. No timetable or anything. In the meantime, Southface created kind of like a stopgap measure, which is basically an Excel spreadsheet that does some of the calculations for you. We're going to be doing a webinar or some sort of maybe a YouTube video that goes through exactly how to use that once we get it updated. So keep following up with us about that, and we should have that pretty shortly.
So it looks like a 3-year-old is writing this, but anyway, that's where you can get ResCheck if you want to use it. And actually, we recommend if you're using our little template that Joey was just referring to for the state of Georgia, you still need to use ResCheck. ResCheck is going to give you some numbers that you'll end up putting into the template. So anyway, that's where you get that, is energycodes.gov.
Someone asked about settling when it comes to blown-in insulation. As far as the standard goes, I don't believe they make any mention of that. That's kind of more of a manufacturer's recommendation thing. I would also caution you against the manufacturer's recommendation. Is it depends a lot on your equipment as well, your blowing machine, how much air you're flowing through the gate. So a little bit of trial and error is going to be the best way to figure out that settle rate. But sometimes it can be around an inch or two, depending again on a lot of factors.
Yes, and actually, if I can jump in, if you dive into Chapter 3 of the Energy Code, they actually do have a reference to that. The initial and the settled thickness is supposed to be on the report card. And if you want, I can try to pull it up, but that is in the Energy Code itself. That is in Chapter 3 of the Energy Code. So might help you, I hope.
Yeah.
And that language has been in there for some time now too. So.
And someone was asking about an infrared inspection be used for inspection after wall is covered in sheetrock. Speaking of the energy code, so you are required, if you're doing energy code inspections, to see the insulation before the sheetrock is installed. If you're doing this after the fact as a HERS rating, the infrared camera can definitely be helpful, but keep in mind it's not X-ray vision. So it can help you, but I mean, I think isn't there something in HERS, if you can't see it, just assume that it's grade 3 sometimes.
Yeah, I believe they were working on a standard for that. I don't know the status of that, of using thermography to determine, but I think what you can use thermography for, infrared camera for, is there insulation installed, yes or no? and then because you can't see it, you default to grade 3. I believe you can do that. And then sometimes programs may or may not allow that. Like I don't know if Earthcraft allows that because, as an example, because we want to actually visually inspect everything, but
Yes.
you know, they might have made an exception here or there on an occasional house, but you don't want to go that route. Obviously, the visual inspection is the critical part of that, and so that's why I think, you know, raters provide so much value, because they actually know to do a rating. I need to show up and do this visual inspection and catch these defects before they're covered up. So
Yeah, and
great
speaking
question.
of visual inspection, I think one of the great videos on our YouTube channel is your installation inspection video. I mean, it's really, you know, quick. You know, there's not a, you know, sometimes you can look at these YouTube videos and they're, you know, 40 minutes long, and it basically tells you two things. But I think ours is nice and concise, and does a good job of kind of conveying the important information. So do check that
And
out.
if I remember right, Joey, we had a $14 production budget for that video too. So you know, Greg did a lot for $14. So
Yeah.
yeah, no, there's a lot of good stuff out there, but I think we've covered the thing. And you're right, it a lot of times is just easier to watch a video instead of passive images. So
Yep. And then I think we had on some of those spray foam fails. I think the one where it's, you know, definitely has those voids around the studs. Someone asked, would you remove that insulation altogether, or maybe just spray into the gaps? As the,
um, yeah, I think this is one I've definitely seen multiple times,
mm-hmm,
and I think you know, this is one where I would say, in my opinion, you probably can. I would do some squish tests and see. You know, sometimes I've seen this where it looks like it's filled the cavity, but if you poke a small hole, you realize that there's a giant void of no insulation. It's like an air pocket, if you will,
mm-hmm.
inside of it. So, assuming that you don't have that, you, I think, could come on top of this and make more passes to try to correct it.
Yeah.
I don't see that being a problem, but I am not an expert at spray foam installation. I think I understand what we're trying to achieve,
Mm-hmm.
and we talked about that being a topic for a webinar, and I have a friend that is just, I consider a real guru on this, and I would like to invite him to be a part of that. So
Yeah.
you know, we can ask that question, but my gut is that you could probably come back and just, you know, eventually essentially spray over this whole thing all over again,
Yeah.
and you know,
I think on the
it's
next
hopefully
one, especially, I do have concerns about the mix. You know, if you leave that, or maybe it was the preceding one, I can't remember.
this one, yeah,
Yeah, so if the mix is real bad there and you just cover that up, then it's potentially, you know, going to leave that bad insulation in there. And then who knows how
I
that's
would
going to
agree.
age as well.
I would
Someone
agree.
is asking about moisture problems within roof decking. I think that this is, oh, there it is, with spray foam. I actually just read a good article on the Green Building Advisor about that very topic. And I would definitely refer you there. But Mike, if you want to take a stab about, you know, if you've ever seen moisture problems with roof decking, especially in northern regions, which obviously we're
Yeah,
no
I
different.
want to. If you're not familiar, I want to point everybody to this last link here, which is buildingscience.com. This is Joe Stiebrick and Coda Una and Betsy Pettit and other great, really terrific researchers. And they have some good information on their website about, um, you know, addressing moisture concerns in spray foam. And I also went to a good session that Coda and Ian Walker did at RESNET, and that was an excellent session as well. So I think this is an open-ended question, so I'm going to suggest maybe we cover this in our webinar on that
Hmm.
topic. So that's
I
how about
like
a
it.
teaser? What a teaser
Ooh,
that is. But
ooh.
in the short version, you know, I think there's a thing called a vapor vent, which may or may not be a valuable thing, and it's still an airtight conditioned attic, which I think is the key thing. And then I'm not sure if the question was addressing moisture buildup or the question was addressing a roof leak. So they're kind of two different animals in terms of this application. So I'm gonna say it's a little off topic. So let us get to that one, and we'll tease you with the answer.
Yeah. Well, the questions are kind of dying down. So
How about a poll?
how about a poll for the few, the proud that stuck around? I don't know if
Yeah, yeah,
All
yeah.
right, let's
Let's
see
see.
here.
Let's see. Let's try it. Let's put a
Yeah,
couple
and
questions
this will
up.
be a little teaser for the people who are going to do the RESNET. Maybe you get a free answer here, but this is a question that I like. Which of these is not required of insulation installed in a framed floor assembly? So the options are must be in substantial contact with the subfloor. It must be permanently installed. It must have the same R value as the attic, or it must be installed to manufacturer's recommendations. So, Mike, I don't know if you can navigate there. Maybe you have. Actually, it
Uh,
looks like almost 70+% did get that one right. It is,
what?
it does not have to be the same R value as the attic. There's a little bit, there's basically two different charts there if you're looking at the energy code. It would be, ideal if you could get that up to an R49, but sometimes that's not always an option there. It always needs to be installed to manufacturer's recommendations, and it always needs to be permanently and substantially in contact with the subfloor. So
Yep.
that was
I like it.
fun.
I like it. Let's do another one. These
All
are
right.
great.
Oh, sorry. Let's see here. And this one I think is applicable. What's the maximum compressed depth allowed to achieve grade 1 on BATT insulation?
Ooh, that's a good one. So
Um,
for that, we're gonna go. Let's see. I found it. I found it on slide 75,
Okay.
but you probably can't see my screen because your poll is open, I'm guessing, right?
Yep.
Uh,
So, and it's actually, I'm glad I did this one because I think we're maybe a little bit confused on this one. So, it looks like it was pretty close between 1/2 inch and 3/4 inch. So, the operative word in this
mm,
question was definitely BATT insulation. So maybe some people got confused. All right. So yeah, we're back to your screen now. So if you want to just walk us through this one real quick.
yeah, and that was a good question. So again, for bats, and that's important that you note the type of insulation for bats. The maximum sort of underfill, if you will, is 3/4 of an inch, and that's for both grade 1 and grade 2. And the
Mhm.
percentages of the surface area is either 2% or 15% for grade 1 and grade 2. So yeah, that's a great question. You want to try one more?
All right. I've got one more left.
Either
And
there's people attending or they fell asleep. I'm not sure, but yeah, let's try a couple more and just see how we're doing.
well, this is the last one I have. So how many
Okay, let's
sides,
try one more.
how many sides must fibrous BATT insulation be in contact with durable materials for optimum performance? All right, a resounding 96% came up with C, which is 6 sides. So
Yeah,
I think we did something right there on that slide, and I think it should go back to you.
got it.
So there it is. I'm seeing your screen now.
Yeah, good, 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 good. Well, I think, as always, want to say thank you again to the everybody that attended. Really appreciate the high turnouts that we've been getting, and hopefully we'll see you see you in, I guess, 9 days will be our next one. So it's next week, Thursday of the following week, and this one's I think going to be a good one. It's about ventilation, and then hopefully the following one also on ventilation, really part 2, which I think uh, rather than me try to cram 2 hours worth of content into an hour, which we made it on time, so I'm thrilled. We're going to try to hopefully have a little bit more time to kind of stretch it out and as always, thank you so much for your time, Joey. Thank you for everything. Anything you want to add?
Nope. See y'all next Thursday.
All right.